Okay, thank you. So my name is ingy.net, and today I will be talking about Acmeism, which means hacking in all languages at once. So, this date right here is who came to Andrew's talk about SNUSP and Rosetta Code yesterday? So this is the number 20 written in a SNUSP program. So today is April 20th. I had a weird dream that Taiwan was going to blow up today, but let's skip that. So, questions? Jesse?
What's your talk about?
Jesse, it's exclamation points, not question marks. I have questions for you.
Oh.
Okay. So, okay. I can't really read very well. I'm going to raise my hand the whole time. And so who here has written a computer program? Okay. Now, keep your hand up and raise your right hand if you have. And then who here has not written a computer program, raise their left hand. Okay. So now, these people that have no hand up, you are a paradox. What's going on? You, explain yourself. You have yet written a program and never written a program. I do not understand. Okay. Anyway, so who's written a program in Perl? Woo! Who has released a CPAN module? Good. Okay. Who's programmed in Ruby? Excellent. Who's released a Ruby gem? Okay. Who's written in JavaScript? And who has released a Node PM package? Couple. Good. I really can't see it. My phone turned off. Okay, more questions. Python? Oh, wow, a lot. And who's released stuff to PyPy or PyPI? Not so many. Okay. Okay, now, who has published to all four of those? Python, Ruby, for PyPy, CPAN, NPM, and no, what, the other one? GuGod, yeah, right? You have. What? You're missing what? Nothing in Python. Okay, it's good. Good man. Yeah. So, I guess nobody's going to say yes to the rest of these questions. Who has published the same package to all four places? And who has written one set of code, test suites, and docs for a package and pressed a single key and published to all four in 1 second? Well, me neither, but I'm getting there. So that's what this talk is about. Okay. So I like to write modules. And for Ruby people, what a module means is actually a package, because they kind of use the name for something different. Everybody uses words for different things. Package is a good word for what I mean. It's something that you would download from CPAN or Ruby gems. It's a tarball of code and doc and tests. And so I think of packages as ideas in a box. And they're also gifts for your friends. So Acmeis, which is this thing I'm talking about, they give more gifts. And those are the places that they give these gifts. Now, it's not limited to that, but this is the start of Acmeism, the dawn of Acmeism. Okay. So what's inside a package box? Well, there's four things, abstractly, if you think about it. There's code, tests, documentation, and some automation stuff like makefile.pl or rake files, gem specs, those kind of things. So every language that allows you to package things, which is all modern languages, have these same things in the box. So as an Acmeist, we have the same things, but if we want to actually press one button and push out to four places, we have to have abstractions for code, tests, doc, and automation. And so the code, the things that I'm working on recently, for code, I have a programming language called CDent. I'll talk about all these things more in the talk. For tests, I have something called TestML. For doc, it's StarDoc. And for automation, it's package. And there's one other project that's very important to all of these that actually builds almost all of these things, and that's called PEGX. And I'll talk about that. So what is Acmeism? It's about sharing your best ideas across borders, across language borders. So I think that, well, it's becoming less and less so all the time. So when I first started talking about Acmeism was 4 years ago, and there was a lot more borders. There's becoming less borders, so Acmeism is just happening. No thanks to me, but it's good. So the barriers we find out are more and more just BS. It's just that we never took the time to actually go and learn about other cultures and share across cultures. Yesterday, Andrew talked about Rosetta Code, and he talked mostly about the code samples in different languages. Rosetta Code, for those that weren't there, is a website, a wiki that crosses 500 languages with 650 programming problems, and people fill them in as they have time. Last week, I took the whole thing and scraped it through an API and put it into a GitHub repo, so you can download all of the samples in 2 seconds and play around with them. So, but the one thing that I haven't scraped yet is all the talk pages, and I read through some of those talk pages, and they're brilliant. You can learn from all these dead languages like Smalltalk, all these, I don't know. I mean, there's lots of culture that goes back and lots of writings and lots of great ideas, and they're completely applicable or largely applicable to today's programming. So think, hack, overcome. So as a hacker, everybody's in a different stage of their hacker timeline of maybe some people are brand new, some people have been doing this for a long time, but this is what I think is the standard hacker's progress through a life is you learn a language, and then you write some code in that language, and then as you get a little bit better, you get a programming job, and that's good, so you can pay for all this fun. And then you write an open source module framework. This is kind of like working towards being a wizard or something. You write some kind of framework and share it on CPAN or Ruby Gems or probably not PyPy. Nobody seems to be into that. And then you give a talk at OSDC about it. And then finally, you start your own religion. So Acmeism is this hacker's religion. You could think of it that way. And Rosetta Code, I figured out, is the Bible, the Quran, the scripture of Acmeism. And OSDC is the Acmeist temple, so welcome. What's JSON-Y? Well, it's not a very popular thing, but JSON-Y is a new DSL. It's just like JSON, but with less stuff, less quotes and commas and stuff. So this is JSON, and this is JSON-Y going back and forth. It just basically you pull out all of the punctuation, and it basically does the same thing. Now, I'm not trying to sell you on JSON-Y. I think it's a terrible idea, but it was an idea that a friend of mine came up with one day, because I actually, I don't know, who knows, but I was one of the creators of the YAML serialization language, so I tend to really like YAML, but other people don't like it, and people like JSON for different reasons. I like JSON as well. Actually, JSON is a subset of YAML, so I like it very much. And but my friend Matt Trout, very loud British Perl hacker, he wanted to make up his own thing for some reason. I still haven't figured out why, but he made up. I just said, well, what do you want, Matt? Because he's not a very good language designer. So he just told me basically what he wanted. And within a couple hours, we had JSON-Y named and up on CPAN. And in 25 other languages, same code, same test, same API. Now, that was me dreaming, but that's where I want to go. So who's heard, maybe I'm jumping ahead a slide or two, but who's heard of TOML, TOML? It's kind of a recent thing. It's basically Tom Preston Werner decided that he didn't like any of this stuff, so he was going to make his own Tom markup language, and then he just put out a spec in every I don't know, he got 20 implementations in 1 week. It's basically like a INI file, nicer, kind of like this would be to INI files. Okay, so okay, so first I want to tell you about PEGX. Now, PEGX is really the big deal of the talk. It's the most technical, cool advancement of Acmeism currently. What it is it combines PEG-style parsing. Who's heard of PEG? PEG means parser expression grammars, and it's the new style of writing parsers for languages. Perl 6 is built around a PEG, and it's one of the most advanced PEGs out there. And actually, the whole language boots up, and you can modify the PEG during compilation time, and it's do crazy stuff. I saw that at a Perl conference, and I was like, wow, the rest of the world needs this. Ruby needs this. Python needs this. JavaScript needs this. Perl 5 needs this. How can we make this happen? So I'm like, well, what do all those languages have in common? They have regexes in common. So if I can take most of the good stuff from Perl 6 rules and somehow magically turn it into regex stuff, then everybody wins. So what PEGX does for you, if you can write a PEGX grammar, and it's actually the PEGX itself is written in a PEGX grammar, and it's about this long, you know, for some font size, but for some pretty normal font size, it's about this big. And I'll show you in a second. And then any language where PEGX works, you have for your new DSL, probably not PEGX, but you know, for some TOML or something, you write a TOML thing, and you have an instant implementation with a little hand waving. You have an instant implementation available in 25 languages, as long as those 25 languages support PEGX. So I am going to show you some PEGX real quick. And, okay. I'll bump this up a little. So my repositories, if you look at this, I have 4 different repositories for PEGX. I have a testml repository, a Ruby implementation, a Perl implementation, and the PGX. I use these suffixes because in Acmeism you have the same name and you have all these different components. For now you do. That may change when everything starts getting auto-generated. I don't know. But let's look at the PEGX repo. So this is the PEGX grammar for PEGX itself, and it's okay. So this is the top rule saying match a grammar. Well, what is a grammar? It's a meta section followed by a rule section. And this actually has some error checking in, so it's a little bit more complicated than, say, a JSON grammar, which we can look at. But basically, everything gets defined in here. It doesn't look too crazy. There's obviously a little bit to learn, but if you can learn that, then you can define a simple grammar and have an implementation in 25 languages. So it's worth your time to do that. Now, the cool thing about this implementation-wise is this grammar is just sugar that turns into this data structure, this terribly highlighted. Oh, it's actually good on the screen. Great. It looks terrible up here. But basically, I've dumped this in YAML. It's just a regular data structure understandable by any language that understands its hashes and arrays and regexes. I can read that in and then write a runtime for PEGX, and I can parse according to the rules of this grammar. So, and you can see everything at the end, all of the tokens, the final matches are regexes. So they turn into these massive regexes. Now, in the grammar itself, you have little parts, but they get added up sometimes to extremely huge regexes, but it all just works. There's a pretty big one. That is for, this some kind of error checking. So does anybody have any quick questions about that? Is it pretty straightforward? Okay, I will keep rocking then. So now, back in my slide over here, I have this cool one-liner that I can use. So I'm going to cut and paste it out of here. Now, I'm going to break this down pretty quick. Basically, I'm including 3 modules into a Perl run. I'm going to run a Perl one-liner with 3 modules, PEGX, IOL, and XXX. So PEGX is going to take a grammar, which happens to be the PEGX grammar that's in this directory, and it's going to turn that into a parser. And then it can parse anything written in PEGX. Well, the only thing we have in this directory that's written in PEGX is PEGX itself. So we're going to actually read the grammar twice, once to make a parser and then once to parse itself. So if your brain is exploding, it's cool. Just don't let it get on anybody else that's next to you. And when we're done with that, we'll just dump the whole thing in YAML. So here we go. So this is a big parse tree. Now, the cool thing about PEGX is it separates the concept of grammar from receiver. And so what a receiver is like a parser parses, it matches events and then passes them to some other class. Now, most grammar languages write the actual logic of what happens after you match something in the grammar itself. I think that's a bad idea because a lot of times you want to use the same grammar and repurpose it for different back-end uses. Maybe you just want to scan through the code and do something that doesn't have anything to do with compilation. Okay, so I'm going to modify this program a little bit. Let's see. This is going to go horribly wrong, but I'll try. I can change the receiver class. Now, you don't usually, this is all one-liner stuff. When you're writing actual code, you create new objects and it looks all good. But this is PEGX exports this little PEGX tool for doing quick one-liners. So I am going to, the default class is this. It's a So this is going to do the same thing as last time, except I forgot my curly brace here. Okay, it gave us the same thing. And basically, it's a big data tree, and every rule has a key, and then what's underneath it is what matched underneath that tree. And I could scroll up and, well, maybe I should just quickly get up to the top of this huge thing. Well, I ran out of space, but you can see it's matching everything in the grammar and putting it into the tree somehow. So wrap means put the actual name of the rule in there. We can do a cleaner tree this way. So now it's just an array of arrays of the data. And when you actually define a class, this is more useful because this is the information that's going to get fed to your callbacks. Now, finally, what you really want to do is have a receiver that does something useful. And what we and produces an AST. And look at this. So that's exactly what you saw in the YAML file. So that's how I generated that. And this can be, I've compiled this PEGX thing, and I can actually port this to other languages that understand YAML or JSON. I can dump it in JSON as well. Anyway, I don't know if any of that makes sense, but it's pretty cool. I'm going to get back to this talk. Now, the other part of PEGX is the next thing. So PEGX has, to ensure that it works correctly in all languages as it gets ported across languages, I have a test suite, and it has to pass that test suite. Well, it would be stupid to write a new test suite for every language because I'd probably introduce bugs. So I have a testing language called testml, and I have so let's look at the PEGX TML directory. So these are all of the tests that test, and all of the implementations of PEGX pass this test perfectly. So let's look at the compiler checks. TestML is a data-driven thing. So all of the code is these two lines. It's saying, look through these data sections, find everything that has a grammar and a YAML section, and then pass it to a method that does a bootstrap compile, dumps to YAML, cleans it up, and does it match this. So here's my grammar, which is empty, and does it make an empty thing. Here's my grammar, which is 3 rules. Does it compile to exactly these 3 rules, et cetera, et cetera. That's basically what TestML looks like. Now, because I'm completely insane, TestML also does its parsing of the TestML language with PEGX, but which leads to true insanity. But anyway, there's actually a bootstrapping version of TestML for testing PEGX. So you can, blah blah blah. So you've seen TestML, and we don't need to look at that stuff too much. So 10 more minutes, yeah, ish. Okay. This is why I think JSON, YAML, TOML, and that project that Paul was just talking about suck. is the idea that they are built off of specifications, right? So specifications is not the right way to write software. I'm not sure what is, but it's not specifications. Basically, somebody like Tommel, you put out a spec, and then you have 20 implementations in a week that are all exactly different. They have different bugs, different APIs, different documentations, different interpretations of the spec. So it's better to write a test spec. That's a better way to do it. But the Acmeist way is to just generate everything from one set of source code, and then you have exactly the same thing on every endpoint. So that's where I'm trying to go with all this. So let's say you come up with a new idea like MST, JSON-Y, which stands for JSON with a little bit of YAML. That was kind of my creation. Thank you. So let's see. Sorry. The first thing you would do is define a once I get your keyboard, am I going to be able to type fast?
Oh, yeah.
Okay, great. So you define a test.ml test suite for it, and probably this is the one. It's just making sure that all of this JSON looks JSON-y, matches this JSON. There's the code, and these are all of the test cases down here. Cool. And so right now there's a JSON-y, of all of this stuff that I'm talking about, test.ml, PEGX, and JSON-y, there's completely matching implementations in Ruby and Perl. They're fully functional and match test for test there. I tried to get Python and Node done by the conference, but that'll have to get done by next conference, or which is actually in a month. I'm not talking about this. The world will be saved by the next OSDC, but and then the next thing you do is define a grammar for JSON-Y and PEGX. So and let's actually look at this, because this should be pretty small. Okay, so at the top level, a JSON-Y stream is a sequence, a map, or there's a special sequence and a special map, or a list. So what do all those things mean? We'll just read the rest of the grammar, right? So the big one here is, oh yeah, I actually lifted this from, this is a double quoted string from json.org. So I just basically used a nice spread out way to implement this, but this will all get turned into one massive regex that you would see in the .yaml file, etc. So you guys all understand that because we talked about it. So, and then the Ruby and Perl implementations are actually quite small. They're just a function call to PEGX, and then you provide a, actually let me show you the magic of, Arking messed me up on this. Andrew knows what I mean. Ruby or Perl? Vote. Ruby, all right, you win. So JSONY.rb is really small. It's just one function that, it's the function that you use to decode stuff. But the important thing is the PEGX receiver, which is called receiver here. And so these are the got match callbacks for certain things, and that's the whole thing right there. So can you read all that? I mean, basically, you get something back from a data tree, and you just return what you want it to look like in the JSON final. So it's actually a pretty nice API. PEGX passes you in something, you mutate it and pass it back out. You actually don't have to have got routines for every callback, only for the things where you actually want to change what PEGX gave you by default. So, okay. Now CDent is the language that I write all of this in, and it's a language that is defined only as a AST. It has no syntax. Actually, it has multiple syntaxes. So I'm using YAML as the syntax right now. I'll take all of these classes and then code all of the information that would be needed to generate the Perl, Python, and Ruby and Node equivalents into YAML. And when I'm done with that, then I create a syntax that is sugars that. And what I'm leaning towards CoffeeScript right now, but with one caveat. I call it Uniscript, and it's not Uniscript in that it's one for all. It's Uniscript in that I use Unicode characters for all of the keywords. So, and CDent's named after my friend Chris Dent. So let me show you. I'll just show you the Uniscript. So checkmark is a require. Lambda is a method definition. Dot, dot, dot is all the args. These are setter getters setting things to nil by default. Delta is the version number. The section starter from Unicode is a class. And so anyway, this is only one syntax that you might use. Anything like, it'll be really easy to make up your own CDent syntaxes. Yes?
Is that all generated, or did you type it by hand?
I typed it by hand, yeah. But so when I have your keyboard, I want Jesse to build me a keyboard that types all of those characters. And then it'll be so easy. Until I add extra keywords, and then I'll be, Jesse, make me another one. Okay. Star doc is CDent for doc, and I'm not going to talk much about that at all, but basically write your doc in your favorite format and publish it everywhere. Okay. So basically what's going to happen when I have JSONY-cd, this one source code repository that publishes everywhere, the main thing is I'll have a package YAML file that will contain meta information that I'll need to do all the generations. It will name the languages I want to support. Then I'm going to have those files written. I'll have Uniscript files or whatever syntax I choose under lib. I'll have my testml test suite, and I'll have my stardoc doc. And then what I can do is these commands. I can say package build. Package build will build 4 at once. Or I can name the things that I want to build. So it'll build them in subdirectories just as I had coded them myself, because my actual implementations will be my tests. So I will make sure that they're as damn close as to what I would have written myself as I can. If I want to test them all, I say package test, and it runs the test suites in the native, rake test or prove for Perl or Python setup py test for Python, etc. And finally, I can just do a package release, and that's, hit enter, and it goes to 4 different places. So what? Well, Audrey Tang, who I think everybody knows, once said about Haskell, it makes writing parser compilers as easy as Perl makes writing CGI programs. And so ingy says Acmeism makes writing multi-language DSLs as easy as Haskell makes parser compilers. That's what I am saying. So, you can come up with your next cool idea, and in one day, write the same code, same test, same API, same doc, same bugs, same fixes, and publish everywhere. World peace just happens, and Shibuya starts the Shibuya.cd Mongers meeting. It will be great. So I have 1 minute left, and I'll go some future plans. I want to finish all the stuff I showed you. I want to do Perl 6 support before YAPC. Perl 6 is actually hard to do because it doesn't have regexes, so I can't do pegx. So I got to figure out a way around that, even though it inspired the whole thing, kind of. Go support looks interesting. Last night, Audrey was telling me about source mapping, which is going to be, when you do CoffeeScript to JavaScript, you have to know when something blows up, what line it blew up in the original CoffeeScript, and that's going to be the same with all this Acmeism stuff. And then the exciting stuff is like, why would you want to code in this way if you're just a Ruby person? You don't care about these other languages. Well, if you could actually get an automatic generated binding to CLLVM or some super fast runtime, so you had 100 times performance speed up, then you would win in Ruby, and everybody, all the other 24 languages would win just because you had done it that way. So kind of cool. And that's it. I got 52 seconds or more for questions. Anybody? Come on. Yeah. So the question is, when people find bugs, where do they fix them? There's 2 places. It could be in your own code, or it could be in my stuff that's generating stuff. Probably in the beginning, it'll be always be my fault, and later on, it'll be your fault. But yeah, if the idea is that, like when I write YAML in this language, all of a sudden we'll have equal implementations. Nobody will gripe anymore, and anybody can fix a bug in the grammar, and it will help 25 languages at once. Another question? Yes.
What's the estimated time to learn to write in that the source language?
Well, if it's like CoffeeScript, CoffeeScript is a big boon to this whole thing because it really, with a little bit, if it's a CoffeeScript modification and people are learning CoffeeScript, I think the time should be pretty quick.
Okay. About the time to learn CoffeeScript?
Yeah.
Okay. Sounds fair.
Cool. Any other questions? Well, thank you very much, and it's great to see you all, and I'll see you next year. We'll have more stuff done.